0 plus a1t plus a2t square. So I'm trying to fit a function between f and t, not a regular function, a more sophisticated one, and that is Gaussian process. Now, like you have a0, a1, and a2 in that expression I just told you, like a0 plus a1t plus a2t square. If you try to fit a curve, this a0, a1, and a2 are the unknowns. Similarly, in Gaussian process, fitting means finding out this parameter theta. So this theta is unknown. And like we are assuming the form like a0 plus a1t plus a2t square, and not a0 plus a1 log t plus a2 exponential of t square or something like that. Similarly, we assume this function kff, which is known as the covariance function. So this is what we assume, a form of the covariance function, and theta is the parameter of this covariance function, which is unknown at this point of time. So I don't know theta. I need to estimate theta based on certain data. Now the problem here is that I don't have any measurement of f. So if you give me, say at t1, f is f1, at t2, f is f2, and so on and so forth, I can actually do a minimization, a loss minimization to find out this theta. But I don't have that. I have no measurement of f. I have measured f never in my life. Or for that system, there is no measurement for f. So if there is no measurement of f, I cannot compute this parameter theta. So what can we do? You remember the governing differential equation from the last slide? I am going to take this f, substitute it into the governing differential equation, and solve for x. So what I do here is I take this f, substitute it into the governing differential equation in previous slide, and then solve a integral problem, because there was x dot, so solve an integration and you will be able to find out x. So we solve an integral problem. And since our system is linear, it can be shown, there is a proof that you can prove it, that if f is a Gaussian process, if you substitute it in a linear dynamical system, as is the case with our case, and then solve for x, this x is also going to be a Gaussian process. The parameters will remain the same because theta is not a function of time and you are integrating with respect to time. So theta will just come outside the integration. Any constant comes out of the integration like that. But this kff is a function of time. So this kff will change, and I'm assuming that this kff will change into kxx. So kxx is nothing but time integration of kff. So if you take this kff, integrate with respect to time, you will get kxx. Now, what we have two Gaussian processes. One Gaussian process representing the force vector, the other Gaussian process representing the state vector. The covariance kernel for both of these kff and kxx are known. Theta for both the cases are same but unknown. Now the question is, can I use this expression to estimate theta? And what is the requirement for estimating this theta? Data. So the question boils down to, do I have